Hey Houdini owners, Dave Brennan with American Pinball Tech Service. Today I'm going over upgrades for your Houdini game. I get a lot of calls and emails from owners that just acquired a game and they heard that there are some upgrades to the power supply, the edit stroke switch, and there's a capacitor kit. And they want to know what they are, where they go, and what do they do. So I'm going to explain all of that in this video. So let's take a look. The first thing we'll discuss is the power supply. If you look under the playfield at the back bottom of the cabinet, you'll notice one of two power supplies. The original one looks like a big donut, like this. If you see a big silver box that looks like a giant toaster, that is the more modern power supply, and you don't have to do any power supply upgrades. It's already done. So with this one, there's actually 3 voltages that come out of this power supply. On the left hand side, this is your 5 volt, which are your red and black wires, and then your 12 volt, which are your yellow and black wires. We're not going to do anything with this side of the power supply. What we are going to do is look at the 48 volt side of the power supply. So you have AC power coming in, it feeds into this bridge rectifier, and then DC 48 volts comes out. This is what powers your coils. So the 48 volt power supply upgrade is really just a bypass for this section of the 48 volt. The reason for the 48 volt power supply upgrade is the original 48 volt section is more sensitive to drops in line voltage. For example, if you were to have an appliance like a furnace or air conditioner kick on during gameplay, or if you have inconsistent line voltage coming to your home, this would translate to weaker coil power in your game. So what you'll get when you get this upgrade is another 48 volt switching power supply that will be installed right next to it. And you'll also get connectors that will basically split off this power. So this connection is your AC that will be plugged into a connector in the towards the back of the game. And what this is going to do is it's going to split the connection. So when you go to connect this up, all this is black for hot or your line voltage, and white is your neutral. And so you'll unplug from the existing connector and you're going to plug in one side. You'll match up, so this, it's keyed, so you're not going to be able to screw it up. So the wire colors don't matter so much. See, this one is red and black, and this is black and white. What does matter is that you get all black to all black and all white to all red, because it's AC power, so it doesn't matter. And then this side goes back to the original plug that comes from your wall outlet in the back of the game. Again, black to black, white to white, and it's keyed so you can't mess it up. Now let's take a look at the connections to the power supply itself. On the new power supply, there are markings on the front. It says line voltage, which is your hot, neutral is white, and then ground for green. And then you have, that's your AC input coming from this connector. And then it's going to go through your bridge rectifier inside this box, and it's going to output 48 volts DC. And that's your black and brown wires. And you'll see that it's labeled V minus for black and V plus for brown. And you'll connect these wires here with these screw terminals. Make sure that these are tight when you screw these down. At the end of these brown and black wires, for some reason, they include these walnuts, which I know, because I read Pinside too, nobody likes these. So the first thing I want you to do is pull these off and throw them in the garbage. Nobody wants them. What we're going to use is standard wire nuts that you can get at any hardware store. This is the easiest thing to use. Anybody can find them, and we're going to use these to do the connection. This is a demonstration because this is on the bench, obviously, but you're going to disconnect the connections on the original power supply by unscrewing the screw terminals and taking the wires out. If you need more wire on the wires that were removed, just take some wire strippers and take about 1/2 inch of wire off. Do this to all the black and brown wires so you have enough to twist them together. Now take all your black wires, twist those together. Now take all your brown wires, twist those together. And then take a wire nut and screw that on to both the black and the brown sets of wires. The last step is connecting your ground wire. This leads up to the power box at the very front right corner of the game. You'll see that there is another green wire just like this, and you're going to add this to underneath the same screw. Since we're on the subject of coil power, there's one other upgrade that you can install that will give your coils a little bit extra power during times of heavy usage, such as a multi-ball. During multi-ball in Houdini, all the magnet coils are working, your flippers are going off, and several other coils are working at the same time. This puts a lot of strain on your power supply, even the upgraded one. So this kit is very simple. It is an inline capacitor for those brown and black 48 volt DC wires that we were just looking at on the power supply. This is a little capacitor board that screws into the playfield in between the 3 magnets, and all you have to do is unplug one of the connectors for the 48 volt power, connect it to the capacitor board, and then take the supplied connector with the kit, plug that into the other end, and then plug that back into the board. I will also post a link in the video notes for the written instructions on this kit. Now let's take a look at end of stroke switches for your flipper mechanisms. If you look under the playfield, you'll see that the end of stroke switch is a leaf switch attached to this bracket, and when you push the flipper buttons, it activates power on your flipper coil. These flipper coils are dual wound coils, meaning that there's a high power and a low power section of the coil. So when you first hit the flipper button, that's high power, and it's going to give you that initial kick of the flipper bat, and then when you are holding the button, it switches to low power when it's at the end of its stroke. Well, early Houdinis didn't have an end of stroke switch. This was controlled by the code. And so what would happen if you had a speeding ball that would come and hit your flipper bat while it's in the held up position, it would hit the bat and then your flipper would die, because there's nothing telling the coil that you're holding that switch in. When you install the end of stroke switch and you're holding the flipper button in, when that speeding ball hits your bat, it's going to open these sets of contacts and it's going to activate the high power of the coil again, and then it snaps it back into the hold position and keeps your flipper bat up. Again, I will post a link to the written instructions for this kit so you know where to connect the wires to install these switches. Here's a demonstration of a flipper with and without an end of stroke switch. The flipper on the right does not have an end of stroke switch attached. So when you hold the right flipper button in the up position and a speeding ball comes down and hits it, it dies. And I am still holding the right flipper button. To get it to come back up again, I have to re-push the right flipper button. On the left, an end of stroke switch is attached. If I hold the left flipper button and a speeding ball comes down and hits the flipper bat, it pops back up. That's how an end of stroke switch works. Thanks for watching this tech tip video. If you have any questions along the way or you need details on something I didn't cover in this video, please reach out to me at the email or phone number listed at the bottom of the screen. Thanks for watching.